Good morning, everybody. Sincerely hope that you're not as hungover as I am. So, I'm Dave Josephsen. I am the developer evangelist at Librato. And today I would like to talk to you a little bit about monitoring, which is sort of a subject that I've been hung up on, spent a lot of cycles on personally. In fact, you may know me as the world's foremost authority in having written technical nonfiction books that have squiggly things on them about monitoring. It's a distinction in which I take great pride. And actually, the first of these I wrote almost a decade ago now about Nagios, so I'm seriously milking it at this point. That's like 50 years in startup time. And it's fair to say that when I wrote this, I had no idea what I was getting into. Like the younger me who wrote this book was not a book writer. He was barely a sentence writer. And it very quickly became clear to me and my editors that I hated editors and really the entire editorial process. I hated the tireless meddling, their ability to destroy what I thought at the time was nuance, but later discovered was just me repeating myself. But yeah, no, they would delete my words. Like I would pull words out of the air, and they would destroy them. They would take like my perfect prose and like give it back to me with like all of this markup all over it. Like I've been to their Pinterest boards, their judgy Pinterest boards. So I know that they're enjoying doing this to me, right? And so I would stomp and rage, and I would argue about every single mark in the entire like return chapter that they would give me. But it was hard because they knew all of these like parts of speech and rules of grammar. Like they had this entire vernacular that they could use against me to subtly make me look silly and feel silly, deeply, deeply silly. So I decided I was going to learn grammar. Because I already knew that my every sentence was perfect. And so knowing this body of rules would give me what I needed to know to describe to these editors why I was right. But I pretty quickly discovered that grammar is not so much a set of rules as it is a set of tools. And the more I learned about the tools and the more I got good at using the tools, the more it became obvious just how awful my writing was. And it wasn't just my writing, it was my thinking. Like my ignorance of these tools and this set of rules had been impeding my ability to adequately formulate and express a thought. I had literally been retarded by my ignorance of this tool set. So also the more I learned about it, the more I would sort of bounce these ideas off my editors. So the more that I began to understand their vernacular, the more I would question myself and use them in the use them in the process of questioning myself. So every time they pointed out something to me, even when they were factually correct, because they were pretty often factually correct, or factually incorrect. Even when they were, I would look at the sentence and I would be like, you know what, I do want to change that for whatever reason. They were invariably pointing out something that I eventually decided was a problem that I now wanted to change. And so learning this common tool set sort of transformed these people for me. It transformed our relationship. Overnight, and from something that had been very adversarial into something that became very conversational and useful to me. So they went from people who gave me headaches to people who gave me feedback. And literally the only thing that had changed was me, right? Anyway, one of my favorite tools that I learned about grammar was the semicolon, which is actually crazy powerful. If you don't know how to use semicolons, then you have a severely limited ability to sort of imply a relationship between ostensibly unrelated sentences or ideas. And it's, I feel like the semicolon is a pretty decent metaphor for monitoring in general. Like everybody knows about them, but not as many people quite know how to use them properly. And using a semicolon properly requires domain knowledge. You have to understand the meaning of the prose to properly implement a semicolon. And if you're writing a technical book, that means you have to have technical domain knowledge sometimes, and sometimes you don't. So the editorial process is really sort of like this conversation that you're having. And nobody can be in charge of semicolons, right? Like you can't have one person sprinkle a bunch of semicolons into the page and then have somebody else like follow up with prose and expect to get something meaningful. Because semicolons have to be everybody's job, right? They have to be everybody's responsibility. So yeah, the editorial process is a conversation, and grammar is almost kind of like this, it's kind of like this interdisciplinary library. It gives you the ability to bridge editorial knowledge with technical knowledge when you're writing a tech book. And that's also true of effective monitoring, right? We need to work with our devs or our ops, or however you're telling yourself you're organized these days, and reason about what you're creating, and use monitoring as sort of a tool in a common grammar for creating web operations stuff. And sometimes you're going to need developer domain knowledge to do that, and sometimes they're going to need operations domain knowledge in order to do that. And in fact, that's true whenever we create something together, like as a team. Anytime there are other people involved, if it's a tech book, if it's a microservices infrastructure, we never say like, y'all want to go grammar? Like, did you grammar already this morning? Want to get some grammar? Like, we can't make a verb of grammar. It's like literally non sequitur outside the context of a creation, right? And monitoring is exactly the same way, except we haven't really realized that yet. So really, the point I want to get across to you today, if you take nothing else away from this talk, is that monitoring is really a grammatical tool in the same way that a semicolon is a grammatical tool inside the toolbox of a larger creation, an engineering endeavor, rather than sort of an artistic endeavor, right? And at the time that younger me wrote that book, younger me was in charge of monitoring. This is exactly like being in charge of semicolons. And it literally made no sense. I mean, and we'll talk about why, but I was basically a subject matter expert in semicolons. Just sort of kind of expertise, but it's not the kind of expertise that most people aspire to, because most people aspire to expertise when they want to create something. Monitoring is not a process of creation. I thought that Uptime was my creation. I thought that Uptime was a thing to be made, right? An engineering endeavor in and of itself, which is a commonly held belief that's gotten us through pretty much the first couple decades of the 21st century. But I don't think it's really true anymore, increasingly, as I age. Uptime is a marvelous thing, but it's rarely the point, right? It's rarely the actual goal. The actual goal is always like selling widgets or running services or, landing Mars rovers. Human endeavor, right, is generally the actual point. But I was obsessed with Uptime. It was my one and only goal. It was my job to stand up systems, run infrastructure services, and make sure all of it remained available. I had no desire to reason about what was happening inside the probably horrible applications that we were creating, developing. So putting younger me in charge of semicolons literally got you Uptime data, because that's really all I was interested in. Let me show you something real quick. I have taken the liberty of grabbing a bunch of snippets out of our sort of daily conversations in the Librato Ops channel. So I took this one. It was day before yesterday, I guess. It's nothing special. We have conversations like this one all the time. And what's happening here is Ben is an ops guy, and he's tracking a correlation between web node CPU utilization in this top graph, so how hard the CPU is working on our web nodes, and high cardinality sources per metric on the bottom one. So basically what you have here is you have an API service that's chugging really hard because it's trying to do lookups to figure out It's trying to resolve source names that our customers give us back to like an ID code, right? I'm going to stop there. Anyway, there are a lot of thingies, right? And inside the application, which is a Rails app, we're chugging away trying to figure out, we're trying to, compute that. But look at that correlation. It's a beautiful correlation. I mean, look at those two curves. That's, I would say that's not the kind of correlation that you see very often, but actually inside Librato web operations, we see this stuff all the time. It's literally kind of the bread and butter of what we do every day. So Mike, who's a developer down there at the bottom, says, yeah, he acts it basically. He's like, well, we know this sucks. We know why it happens. We can spin up instances if we need to solve this, and that's fine because the roadmap is going to catch up with this behavior and it'll go away. But the point is that this is dev and ops having ad hoc conversations about emergent behavior inside applications that are correlating to hard system metrics, right? Before I joined Librato, I never had the ability to do this. I could not ever have a conversation like this with a developer on any of the teams that I've ever worked with before joining on here. I mean, think about the domain knowledge that Ben needs as an operations guy to just make this correlation among however many metrics that we have available to us, right, in the boards. Even if he's come across this before, even if he's been trained, even if someone has said, oh yeah, I know what that curve is, it's this behavior. Even if those things are true, he has more domain knowledge about what's happening inside that application than literally I ever had as Mr. Monitoring expert in charge of semicolons at any operations team that I had worked at previously to this job, right? Because my developers always operated in this completely separate sphere of reality. They made things, right? And those things made money. So they had money, they could spend money on things. So if they wanted to understand what was going on inside their stuff, they'd buy the APM tool, the cheapest or the best one they could afford. And meanwhile, I was literally a cost center. I was this burden on the business, so I couldn't spend any money. So I was constantly wiring up Nagios to graphite to whatever. So I would spend headaches and they would spend money, and then we would never look at the same place, right? They would always be looking over there and I would always be looking over here. It never even occurred to us to have a conversation about this stuff. We believed that these were separate undertakings. This is the DevOps view of almost, right? It's yeah, we're DevOps, we're together, we're optimizing local optimizations out of the system, and it's all great, but monitoring is still a thing in DevOps. We've just created more categories of monitoring, more grammars, right? So now they're grammaring over there and I'm grammaring over here, and we call that APM grammaring, and we call me, availability grammaring. And we never get around to actually bridging this domain knowledge gap. Let me show you something else. This is Ray, who's a DevZ person, and he's like, hey, I have a spike in service X. And then there's Benjo again, who's the ops guy, agreeing with him, basically saying hey, still seems to be getting worse. We haven't peaked, right? Oftentimes in my life these days, the tip of the shark fin graph is yay, peaking. But this hasn't yet, and it's quite a bit larger than, right? It's definitely not nominal. So I'm just going to go ahead and somebody catch this thing for me if I threw it really hard in that direction. Shut up, pager. Okay, so we're making two observations here, really. Ray is saying, hey, service is spiking. And Ben is yep, getting worse. And that first observation is kind of objective. That's in the alert. Everybody knows that. We saw it, we read it, we know where it's spiking. The second is a little bit more subjective, right? He's describing a behavior. And when he does that, and I think most of the engineers at Librato have this tick now, where if you're describing something a little subjective like that, you'll just blurb the data. Because you're looking at the data, why would you try to describe it It's like sort of right there, you know? Picture worth 1,000 words. And now there's a whole bunch of stuff that doesn't need to be said because it's right there. We know, you know, when it started, we know it hasn't peaked, we know where it is now, we know how far it's been going or how long it's been going up. And monitoring has totally become a common basis for communication between these two engineers. Like we have grammar here, right? So again, I'm just trying to point out, like engineering, like really good web operations engineering is a conversation just like the editorial process is a conversation. We've created a thing, and now we're having a conversation about our creation. So whether it's a book or it's a microservices infrastructure, really what we need is a grammar. We can specialize, we can be devsy, we can be opsy, we can be writery, we can be editory. We can take responsibility for like one part or another part of this creation. But at the end of the day, we're going to have to be interdisciplinary enough to be able to talk to each other about it. And in order to talk to each other about it, we need grammatical tools, right? Otherwise, we'll just stomp and rage and get mad at each other. And what you're looking at here is very much, in my opinion, a grammatical tool. You can't put one person in charge of the monitoring tool chain and expect to have conversations like that one. You won't. I mean, I never did. Maybe you will. I never did. Younger me didn't understand exactly that, right? And therefore, I couldn't have conversations like this one that Ray and Ben are having. I couldn't draw this graph. I couldn't draw that line. It's a line I literally couldn't draw. And it wasn't because I lacked this or that piece of software or this or that vendor's tool, right? I just had no means of understanding, like, devsy things, right? I had no means of having conveyed to me how, you know, the critical components of this thing that my business had created, right? And so I stomped and raged at my devs, and they stomped and raged at me, just like I stomped and raged at my editors. I'm going to show you one more. I'm going to show you a bunch more, actually. You may want to just settle in. So this is Mike and Peter, different dev, different op, same issue, okay? One day later, same exact service, same exact type of spike. So exactly the same cardinality spike. We look into it, subjective claim is made, subjective claim is backed up with data almost immediately, right? Everyone immediately on the same page. So my point here is, like, when you treat monitoring like a grammar, you can swap out the people and you literally get the same conversation, right? It's kind of a priori and silly, but yeah, you know, just ask yourself, are you having those conversations? If you're not, I mean, if you are already, then probably don't settle in. There are other talks. But anyway, everybody that knows this grammar can have all of these really useful conversations because although there is specialization, this grammar bridges the disciplines and semicolons literally belong to everyone. Dev can say, you know what, based on my understanding, my domain knowledge of X, I know how this service works. I bet that this problem is causing a drop in, you know, metric Y. And ops can put their hands on the data. They can be like, oh, well, let's go see. They put their hands on the data, and they share it, and they're like, hey, look, you know, you're right. And dev can be like, yep. Or someone can say, like, I pushed a change that should improve the memory management of this service, and then they can watch it in real time. Because nobody's in charge of semicolons, right? Everybody understands how to use them, and just like with me and my editors, this grammar sort of enables these ad hoc conversations about, like, hey, I'm about to make a change, I think it's going to do foo, and then everybody can watch and see if it does foo. So, probably not the last one. In this snippet, Jared and Mike, both devs are trying to figure out a problem with the service that we run internally. It's a service that we call Euler, or Euler if you didn't go to college. I didn't. I'm not making fun of you. Like I've been calling it Euler for the better part of 10 years. Everybody like cracks up. Anyway, so it's basically a service that enables like a user to take some number of ad hoc metric streams and combine them together using math, right? So if you're familiar with graphite functions, this is that as a service. And it's not an easy service to run, by the way. This is exactly the sort of thing that it's very easy to DOS yourself with. Because literally it's like, hello user, like here's an interface you can use to make our servers perform ad hoc computations on arbitrarily complex time series workloads using like any amount of data that you've stored in the last 365 days. So like have fun with those type globs. And we'll call you in a week when we're back up. So like a lot of tuning is my point, goes into a service like this. You have to understand its internals very well to sort of detect when it's about to go sideways. And it's difficult to reason about where the bottlenecks are. It's difficult to predict how your customers are going to break this service for you. So to do this well, you have to measure things like how long it takes to actually perform or render a computation of a given type, right? And that's what we're visualizing here, is we're literally saying how much time does it take to perform a derivative, right? And of course, this is another impossible feat for me to achieve as younger monitoring expert, because this is hardcore domain knowledge. Like, you really have to have built this service almost to even know that you need to monitor something like render time on computations. So you also need to make this measurement from inside the application. Like, there's no other way to get this other than to instrument it. So to draw this line, you need not only really solid tools expertise, like what we would consider traditional monitoring expertise, but also hardcore domain knowledge. And I only ever had the former, and everyone with the latter was a yucky Microsoft using person who didn't want to talk to me any more than I wanted to talk to them. And we all suffered as a result, right? The point is, like, if you think like I thought, and if you think like they thought, that monitoring is a thing, it stands on its own, then you won't ever draw lines like this that encompass actual metrics about service health, and you won't have your aptitude will suffer. You will not be good at the end of the day. You won't be good engineering squad-wise at running services like that one, right? Which is definitely, like, now we're into the realm of like competitive advantage. You will, or I would just sort of like string together these tools. Like, you'll wire Nagios to Graphios to StatsD to Graphite, and you'll make some CPU graphs and call it a day. It's like, yeah, data. I mean, just getting data is like, wow, look at that, I have data. I can go home. And if something goes wrong, you'll basically just rub your chin and stare at the CPU graphs, because that's what you have to stare at. And when they don't really provide insight, maybe you'll buy into this fallacy that you need better tools to provide more data. Tomatoes at the ready. You'll choose a tool, right, like tool A versus tool B, because one of them has 4,000 metrics, as if tools have metrics. And like tool B only has like 500 or whatever. Or maybe like having already been stuck with, right, like tool B because their salesman had an awesome Scottish accent and took your boss golfing. Maybe you'll like bolt on tools C and D to it so that you can get more metrics, because clearly more metrics are what you need, and then you'll have 17 different data collectors wired up to send 1 million metrics to 5 different metrics processing systems, and you'll never bother to look at any of it, because when there's a real problem, you won't actually understand how the data is derived. You won't understand how it's being measured, or how it's being named even. So like, here's some thought leadering for you. This is totally free, and I'll be here all week if you want some more. For a metric to be useful to you, you have to know what it means. Some hardcore thought leadering, right? Like, so how often is that collector polling, right? Like, what precisely is the collector measuring? How is the data being summarized between point A and point B? It's not impossible to make sense of like 4,000 metrics that someone else has chosen for you, but man, you have to really dig in. I mean, you have to like, do your homework. You have to understand what the names mean and how the collectors work. And at the end of the day, you probably shouldn't be that invested in monitoring. Like, you have real work to do, and monitoring isn't a thing. So you should be invested in results. You should be choosing the data that you need and not the tools that you need, and then you should be working backwards from there to get the tools that you need to obtain that data, right? Like, make data the first-class citizen. Have you seen this? Everybody seen this? Measure everything. Younger me was in love with this. Like, I loved this. This was like, yeah, this was my jam. Like, monitor everything. I no longer have any idea what this means. Like, I have no idea. I mean, I kind of get it, right? Like, I kind of get it in the sense that, like, we live in this really weird universe, and there's no now, right? There's no, like, quantum unit of time that we can define as being now. Somehow we just exist on this infinitesimal line that we can't measure between stuff that has already happened and stuff that hasn't happened yet. Now, that's history. Like, was that now ever actually now? Stuff never actually happens. It just is in a perpetual state of having already happened very recently. And now all this stuff happened in our computers, right? And some of it was logged and most of it wasn't, right? And now it's history because it was unobserved, right? Like, it wasn't recorded. So it happened now, and now it's lost forever. Escaped into the past, unwitnessed. And how many millions of those things on how many thousands of our computers were important and how many of them weren't, we can't know. We have to measure everything because we won't have it later unless we measure it now. We won't have it when we try to figure out later what was happening inside our systems. Like, this is FOMO. Literally, what you're describing to me here is probably the ultimate expression of fear of missing out, right? Like, even if measure everything was possible, which it isn't, you would never find anything. You'd never be able to find anything in this huge pile of everything. You have a pile of everything. Let me show you something. So here's Mike and Jared again. They're troubleshooting the same, like, do math for me service. And it's gumming up the works now. So it's taking too long to respond for requests. So you can imagine, like, we have this front-end API that's wired up to a queue, and this service isn't popping stuff off the queue fast enough, and that's putting back pressure on the queue, which is putting back pressure on the API. And Jared suspects this is because there are, like, too many user requests going on. Like, literally just people are trying to do too many math problems, like high cardinality of problems. And so he looks, at the cardinality data to check that out and see if that's what's going on. And yeah, sure enough, it looks pretty aberrant. You can see he put, like, smoking gun there at the top. And this is a cool one for me to look into because Jared sees the cardinality data, but initially he's not precisely sure how we're taking those measurements. He didn't set it up, and he wants to just kind of be sure he knows what it means. So it's not as if inside Librato, every metric we come across, we know intimately. So he goes out and he actually figures out, hey, he goes, looks at the instrumentation. He's like, oh, we're using stat-C timing on a number of requests Bowman here. And then he goes and, based on that knowledge, actually follows up with correctly interpreting and visualizing that data. And then, based on that, he can take some action. So he basically bumped the thread count on this service. He fed it more workers, right? So, and here he is, he's using telemetry data of the problem in progress to observe the result of feeding this problem more workers. And that looks promising. He's like, yeah, that looks like it's going down. So Mike, who's another dev, moves forward into, like, the stack. He moves forward toward the customer-facing infrastructure. Like, remember, this was backing up into the API, so Jared was working back here at the service, and he's looking at very service-specific metrics. So Mike just skips straight to the front. He's like, hey, how is the API baking? Does the data up there look better? And yeah, he throws in his data. And he's like, yeah, the API latency does look like it's slacking off there. So, at this point we can say, like, Jared's change has unblocked this service, right? Which has in turn sped up the API response time as observed by our customers. So in that little issue, we had like 3 or 4 different custom metrics, pretty normal for us to go through at least that many, troubleshooting something day-to-day at Librato. We'll detect a problem in some kind of front-facing, like, custom metric, and we'll dive in from there. And you just sort of, and that's really what it feels like. It feels like diving, because you're going deeper and deeper. One just sort of naturally leads to another, which just sort of naturally leads to another. There's something about our monkey brains and sort of data revelation that just sort of, it almost just grabs you by the nose and leads you where you need to go. And just about every time, and I mean like high 90th percentile, we have all the data we need. Like when our nose gets pulled in a direction, we have the data we need to look there. And we do all of this by selecting individual metrics by hand as part of our engineering process. And I say by and large, like we do have some collect D going on, but by and large, what we're doing is we're literally tracking individual metrics one at a time, adding them every day, taking them away every day as we need, as just part of the engineering process, as part of writing this book, as part of building, right, like these creations. So we don't measure everything. And I'm not going to pretend that's an easy thing to do or an easy thing to get to, because obviously, having personally failed for the better part of 10 years to achieve it myself, I know that it's not easy. So I wanted to spend the last little bit of time I have working through a little homework assignment with you. It's a very difficult one, but if you do it, it will take you from being in charge of semicolons or wherever you are now, with whatever combination of tools you have today, to a better place. And I'm not promising like you'll be in Narnia. I think that's his job, to take you to Narnia. But like, yeah, you'll be in a better place. I will promise you that. Step one, get architecture diagram, okay? So you basically just go out and you're like, hey, what does our stuff look like? Somebody dump an architecture diagram on me. People will be happy about you asking for this, because they go through a lot of work to draw these, and then nobody asks for them. So I've always been happy when anybody asks me for an architecture diagram. Like, hey, man, cool, here. It'll probably have lots of boxes on it, possibly also circles, and lines will connect them. I'm such a patronizing jerk. Sorry. So step two, label the lines. Chances are you have a bunch of boxes with labels on them now, right? Ignore the boxes with the labels on them. Focus on the lines. You're interested in the lines. You want to put a protocol label across every line in the architecture diagram. Step three, name the lines. So not only do you want a protocol, you also want a human person's name. So go out, like get out of your chair, go out, figure out who the person or people are who own that line, right? And not like the DB team. I'm talking like Shannon or Joe. Get out of your chair, walk over there, ask them questions, put their name on the architecture diagram next to their line, right? Step four is all on you, and it really sucks. Measure the latency of each one of these connections, okay? Beg, borrow, steal, use whatever tools that you need to use. Use Node.js, use Windows, get uncomfortable, use a Commodore 64, I don't care. Just measure the latency data on those lines. You want a data stream that gives you those numbers in milliseconds. You want probably a single endpoint address or some kind of balancer endpoint address. And you want, like I said, millisecond data, the number of milliseconds each one of these services takes to respond to a query. You want that on the order of less than 60 seconds. And this is what at Librato we call inter-service latency data. It's so useful because whenever you have a problem, something is going sideways, it actually gives you physical proximity to problem, right? It shows you where stuff is actually happening. It doesn't necessarily show you what, but we're getting to that. And this is going to suck for you. It's going to take you months. You're going to have to throw up some new tools. You're going to have to learn some new tools. You're going to have to, throw up some new data collectors. You're going to have to do a lot of people work. You're going to have to have meetings. You're going to have to communicate. You're going to have to stay on top of people. You're going to have to follow up. And on the technical side, the goal is to gather all of these numbers in one place where you can graph it with a line graph. You're going to want to make sure that whatever that place is, anybody can send data to it. This is not a thing you lock down. It's a thing that you make available. And the protocol should be very simple, or it should have a lot of clients available. So I said don't choose tools, but you're probably looking at either supporting StatsD or Carbon at the very least. Step 5, watch the data. Use your monkey brain. Don't set up any alerts. Check the numbers every day, and as you get more and more of them, you'll start to know them. You'll see periodicity happening, right? You'll see anomalies happen. You can't help it because, again, monkey brain. So every time you think you see a pattern, or every time you think you see an anomaly, you go to your architecture diagram, you go to that name, and you put the graph in their face, and you say, hey, check out this graph that I drew of your thing. And step 5 sucks for Shannon and Joe, right? Step 5, very few people enjoy being sort of like spontaneously presented with data they can't explain. So they'll get fed up with you very quickly, and they'll roll their eyes and sigh when they see you in the hallway coming in their general direction. But that's fine, because it means you're making them think about their service. And usually you'll get a reply like, oh, that's backups or whatever. But every now and then you'll get like a, that's interesting. Like when they've had their caffeine, there's usually an optimal time. You may want to put that also on the architecture diagram. Like, before 2 p.m., after 10. Anyway, whenever you hear that, like, the Calvin and Hobbes scientific progress goes boink thing, proceed to step 6, which is sharing the love. And this is where you help the service owner to sort of add the instrumentation that they need to be able to explain this behavior they don't understand. Because some of what you're seeing, a lot of what you're seeing is going to be unexplainable given the data that you have at your disposal, and that's fine. So figure out what you need to add. Does that latency spike correlate with like upstream request cardinality? Well, you're going to have to actually count the requests in order to find that answer, right? And that's how real metrics happen. That's how you get metrics that like, oh my God, the CPU is paging me again. Like you can throw away your CPU pages at that point. Like when these metrics start flowing into what you're actually doing is you're manifesting systems knowledge, right, into an actual thing. Call it a KPI, call it what you want. And this is also how the relationship changes, because they get to learn about, like Shannon and Joe get to learn about the monitoring system, that it's there, that it's easy to use, that they can rely on it to, right, like understand their stuff. And you get to learn about their services. Like you get to have this conversation where you're like, hey, like what do we need to know to understand this spike that happens every 14 minutes? And then you get to know how their service works. And then later when stuff goes sideways, you get to get back together. You already know them, they already know you, and you kind of both understand. You have this sort of cognitive, this cognitive entity that like, spreads beyond your brain and into theirs. Like it sort of picks up somewhere in the middle. You have all of this tools knowledge and they have all that domain knowledge, and together you've measured it, right? And you get to have like really useful, meaningful conversations. So, I think we have some time for questions, comments, and points of clarification if you guys want. Not usually huge on it myself. Not my favorite thing in the world. Asking questions, big on. Answering questions, not so much. But I am told by the LISA organizers that you are welcome to ask any questions that you have at this time. Thanks. Sure. The question was, can I repeat step number 5? I don't know, Keynote. Can I repeat question number 5? Here we go. So, yeah, step number 5 is you're just watching data. And I don't know if you've ever done this. I've had a lot of experience doing this where I will just sort of get onto a new team, and they'll be like, here's our monitoring, hand-wavingly in the direction of their graphs, and I'll just kind of sit down for a day and be like, what does that mean? Literally nobody ever knows. This also happens a lot. Okay, so even at Librato, like one of my favorite things in the world is Nick, who's our community marketing manager VP guy. Awesome, amazing guy. He's just like this openly curious, not technical person. And we're Librato, so we have like all of these huge screens everywhere that have like all these important looking graphs on the wall. And Nick will just be like having his coffee, maybe looking at, like, he'd be like, what's a unicorn? What does this mean? What does that mean? And every once in a while he'll point to something and be like, what is that behavior happening right there? And it'll be like our CTO, like Joe will be there, and he'll look at it and he'll be like, it's nothing, right? Favorite thing in the world. And that's what's happening. You're just sort of like, just openly questioning, like, what does this actually mean, And that's totally, it's so important, and it's this process of, becoming familiar with this beating heart that you have, become somehow responsible for. You literally have 3 seconds, and I'm running like hell. So the question is, I talk a lot about not alerting on things. Just thinking back, I know I probably mentioned it twice. I mentioned it probably here in step 5. I said don't turn on any alerts. Really what I'm saying is in step 5, you're not to the point where you have meaningful data to alert on yet. So you don't want to get inter-service latency data up and then immediately start alerting on it, because it's a great way to sort of crush everyone's excitement. Because now, okay, now I have at 3 o'clock in the morning on my pager, you know, at least when I get paged for CPU, I know what a CPU is. You know what I mean? But like if I get paged for like, how do you label your inter-service latency numbers? You're going to have to label them in a way that other people understand them, and you probably haven't yet, right? And so now people have this thing where they're like, what is that? And you're a jerk, and I don't want to listen to anything you're saying. So you can sabotage yourself very easily by turning on alerting. The other context I probably brought it up in was the CPU. You know, I think I just threw out there, you can turn off your CPU alerts. And what I mean by that is that, so I'm a vendor. I'm not actually like, I understand very well this relationship. Like having been where you sat, like at the end of the day, I am trying to sell you a thing. So take what I'm about to say for what it's worth. But like a lot of us have a lot of tools that are feeding us a lot of data that we don't understand and that we don't, that just aren't helpful to us because we are tools focused. We are not data focused. We play too much with monitoring tools. We don't play enough with monitoring data, right? And so, like, just think about the thing you're using, whatever you have, if it's Nagios, if it's a Shinga, if it's Datadog, whatever it is, like, they've given you this body of stuff, and it's some subset of that is alerting you back. And the point I'm trying to make is that once you move past, you know, collecting metrics like some kind of compulsion, and actually into understanding and cognitively, like, loving the metrics, you get to turn off a lot of stuff that's just not useful. There is definitely there's this point at time where you're like, wow, can I actually turn off my CPU alarm? I mean, it feels like this fundamental thing that I need to know. But when you get into the realm where you have inter-service latency data, you're tracking things like the size of a queue, so that like hours before something actually goes sideways, you're like, what's happening in that queue? And then you can like, you know, sort of nosedive into, oh, look at that. We have a customer who is, you know, who has suddenly turned up 30,000 servers. Do you think they know that they're paying us for that? And maybe we should give them a call. And you know what I mean? Like all of this stuff happens. And all of that stuff that you thought was important before, it just isn't. It's like, yeah, this is a complete waste of time. I don't know what I was doing for the last literally 10 years of my life. Okay, that got a little, sorry. Overshared there a little bit. My bad. Yes. And we're out. Thanks, guys.